Hi everyone. This is a supplement to Lecture 4 on functions, and this example is an example in Python. So I'm going to walk through some of the functions in Python and show you some pieces of them. Excuse me, some pieces of how we do that in Python. Okay, so let's just sort of skim through and look at what we have here in our example. The first thing I'm going to talk about are modules. Or sometimes I'm going to call them libraries, just as another word. Then we're going to talk about function syntax, exactly how do you define a function and call a function. Then we're going to talk about order of definition and scope and try and figure out a little bit about local variables versus global variables. Okay. So the first thing to talk about is libraries. So there are some built-in functions in Python, and then there are also many modules that contain many other useful functions. And this is actually one of the most valuable things about Python, is the many modules that are available written by other people that allow you to do some very useful things. Okay, I provide links here, so I'll go ahead and open up a quick browser. And so if I take this guy right here and I look at, this is a link to the documentation of Python. So just like we had documentation for Excel, there's documentation for Python. And documentation is extremely useful and valuable to be able to read. A lot of the syntax that you learn in coding and in numerical computing is stuff you don't really want to memorize per se. You just want to be familiar with it, and then you're going to forget, and you want to be able to go back and look at exactly how to do this. And so you want to be able to know how to look it up, and Google is your friend when doing this, but also recognize that Google a lot of times is going to take you to something like the documentation. And so learning to understand the documentation and how you're reading it is really useful. Okay, so this gives a list of the built-in functions in Python. Notice that that's not that long of a list, and Python is instead going to rely on modules to allow us to have many other kinds of functions. So for instance, if we want to do math, you can look up the math documentation, all right, and find out what the different functions are there. Okay, there's a long list of them. Mostly in this class, when we do math, we're going to use what's called Numpy, which is a module called Numerical Python. It has many of the same functions as math has, but it's got some extra things that are really nice. So the Numpy documentation looks like this, and here is a list of a bunch of the things you can do. All right, and so suppose I want to know about let's just see what they have. Just scalars. I don't know if this is going to tell us about data types. We learned about that last time. This is how you define some different kinds of data types. I don't really want to go into that right now. I was just hoping maybe they'd have some mathematical functions. Automatic domain. Do they just have simple mathematical functions? Linear algebra, polynomials. I don't know, import math. It's not really one I want. I thought maybe I could just see real quick where the math functions were, but I'm not seeing it off the top of my head. Maybe we just do a quick find. Math. There they are. I just couldn't see it. Mathematical functions. All right. And here's a list of all the mathematical functions that they have in Numpy. Okay. Rounding, sums, exponentials, floating points, arithmetic, etc. It goes on and on and on. Okay. There are others that we're going to talk about. We'll talk about this one called SciPy, Scientific Python. And when we do plotting, we'll talk about matplotlib, this 2D plotting things we have. Okay? So modules can be imported using the import keyword, so import math. And then once you do that, you need to call the function using the module name. So you're going to call a function. Remember that you call a function by putting parentheses around it. So if I want to call a print statement, I say print parentheses, okay? And that is a function, and I might give it a thing like my name, Doug, okay? And I hit enter, and it executes that command, okay? So if I want to look at something like call sine, so say I want to find sine of 3.14159, I hit enter. Okay, it doesn't know what sine is. That's not a built-in function. So to get around that, I have to do import math. And then once I do that, I call math.sine. And I can now give it 3.1415159. 14159, enter. Okay, and that's a really small number because this sine of pi is 0. All right, so that's what I'm doing here. I'm printing out, so I have this math.sine, and it turns out that math also defines pi. Okay, so if you want to access the things that are inside a module, you need to give it this dot. Okay, that tells you to go look in this module math. So let's run what's going on here. So I'm going to hit Control Enter, or Shift Enter, excuse me, and these are code blocks in Spider. And so when I hit Shift Enter, it just runs that code block in yellow. So I hit Shift Enter, and what happens? Okay, I've imported this. I've done a bunch of things. I've taken the sine of pi over 2. I've defined this array. Don't worry, we'll do arrays in another day. I've defined a two-dimensional array or a matrix, and I've done some linear algebra on it, and then I've printed them. Okay, so this is just to show you that I can do importing. Notice here that I imported Numpy, and I put this as command. So now, instead of having Numpy be something, I have NP, and that is my Numpy module. Okay, so I don't want to, it's kind of annoying to write math.py. It's even more annoying to write numpy with 5 characters.py. It's slightly less annoying to do np.py, and now I only have to type 2 characters. So I've renamed numpy np for the purpose of calling things. So now I can say x is equal to np.zeros, and zeros is what prints out this array of zeros I have up here, or at least makes an array of them. And I can also pick certain things inside modules and just import those. So here I'm saying from SciPy, so go inside the SciPy module and import just this one function, or this one submodule, which is called linalg, which is for linear algebra. Okay, and then I can just call linalg dot, this is an inverse, I'm going to find the inverse of A. If I didn't do that, if I just did import SciPy, okay, now if I wanted to call it, I have to call scipy.linalg.inverse of A. And all of those dots gets pretty annoying, so you can get rid of the 1 by saying from SciPy import that inner module inside of it. Okay, so that's modules. So now let's look at function syntax. So remember, syntax is just this word we use. Maybe I'm going to come over here and clear this. Syntax is just this word we use to say how we have to be, very specific to the computer to define it. Okay, and so to call a function, like I said, you just say the name of the function, prepending it with the module, and then you give it parentheses on both sides. If it returns a value, so if I do math.cosine of math.pi, this should give me 1, right? Or minus 1, excuse me. That returns a value, I can have that value get assigned to a variable. So I can say y equals, or y is assigned to math.cosine math.pi. Now if I print y, that gives me minus 1. Okay, so that's calling a function. How do I define a function? We talked about this in class, but to define a function I use the keyword def space, and then I name my function, no spaces in the name, and I give it parentheses, oops, I did that, and a colon at the end, and then whatever I want inside my function, I have to put an indent after it. Okay, so I can run this guy. Now notice what this did, if I just ran this code block, it printed cosine of pi, but it did not print wahoo. This is defining my function. It's not calling my function. To call the function, you need to type my first function, parentheses, okay, and run that. Now it will run it. Okay, so to call a function, you need to do just like you did with math.cosine. My first function, parentheses, enter. Now when you run it, now it prints wahoo. Okay? Functions, so this function didn't take any arguments. I just put parentheses, close parentheses, and it runs. But if I want to pass in values, if I want the function to act on certain values, I can need to put them as a comma-separated list. Okay? So if I wanted to sum x and y, I can just type this guy, define some values x, y, and this will print x, y. Okay? I run that. What happens? I had to run, so that was my definition. Here I'm running my print, and this prints 3 and 4.2. Okay? That doesn't really sum them. That's not that valuable. What I wanted to do is actually add the two numbers together and then have that one come out. Okay? So to do that, I use the return statement. So the return sends it back out. That's how I can define something. This math.cosine is returning a value that will get put in y. So I give it the return keyword, and now when I run that one, okay, that one will add 3 and 4.2, and it will print that out based on that print statement. Okay. So notice that return is also the very end of a function. So if I put return here, if I take the difference of x and y, it will never run this print statement because this print statement is indented, and that indentation tells me that I'm inside this difference function. So when I run this, notice 7.2 from this guy, but nothing from this piece here. Okay? Now if I get rid of the indentation, now it says, now I'm not part of that function anymore, and when I run it, it does indeed print that. I usually like to give myself at least one space below my function to make me feel good about getting rid of that indentation. That just helps my code be more readable. Okay? You can return more than one value. You just put a comma-separated list, right? That will return what's called a tuple. So it will return 3 squared and 5 squared, 9 and 5, right? Finally, if I put a triple quoted string, so if I put 3 open quotation marks at the beginning, this is what's called a doc string, and it provides the help for a function. So when I run this, right, this tells me if I want to square it, I can put, I put whatever my documentation is. Input x returns x squared, the type, and then I say, type help square it to see these comments. Now I type help, parentheses, square it, and that's what happens. Okay? I can do lots of things. Type help math.cosine, and I run it, and what does that say? It says help on built-in function cosine in module math. And it says, here you go, this returns the cosine measured in radians. Or help numpy.fft.fft. Okay, this tells me about the Fourier transform in Numpy. Okay, I don't expect you to know that, but I just wanted to show you help can print out a lot. Okay, so I defined one. Now I have help square it. Okay, and it will look that up and tell me about it. Okay, all right, so that's how I define functions and call functions. Please note the difference between defining a function and calling a function. Defining a function just says what it is. Calling it makes it run. I define it using the def keyword, and I call it by just typing the name of the function with parentheses. Okay, the last piece is order of definition and scope. Okay, so a function has to be defined before you can call it, before it is used. So if you write some code like this right here, where you put the definition below where the function is, it won't run, and Python will get grumpy. Okay? This says name, F below is not defined. It does not like that. It will not run it. Okay? Now, you have to be a little careful. Sometimes you can run something, and F below could have been defined up here, and then you redefine it down here. It's going to go with the one that happened first. So code runs in order from the top to the bottom. And so it's going to run from the top all the way on down. And if it can't do this, it's going to get grumpy. Okay, it's going to give you an error. Okay, this can be kind of annoying, right? Sometimes you want to define functions in different places, maybe. So what I do is I try and put all my function definitions at the top of my code so that this doesn't happen. And then if you want to organize your code in a way where you have a bunch of different kinds of functions, suppose you want to call something before, you can make a function called a driver function. And a driver function can use the other functions, but then you don't have to call it till later. So I don't know if I explained that very well, but suppose I wanted to use f below, I have a new one down here. I'm calling it f auxiliary. All right, and what that does is it returns x squared. Now suppose up here I wanted to define something that would run f auxiliary, and I wanted to define it at the top. I want to define it before I run f auxiliary, kind of like I did up here, right? I want to have it run before. Well, instead of having it run before, I just define this extra function called a driver function. And this maybe seems a little silly in this example, but maybe I have 3 or 4 of these auxiliaries and I want to call them in a certain order, all right? And so I just define them all, and this is just defining it, but it hasn't run anything yet, so the code is okay with that. The code is okay relating these things to each other. And then I call it down here on my driver, and this guy will run. Okay, this will print out 25. So this driver function allows me to organize the use of other functions. Okay, so what about this one? Take a second and look at this code and decide, will this code work or not? What do you think? Okay, the answer is that it shouldn't run. Okay, I did my driver function, I have my auxiliary function, but I'm calling the driver function, which will call this auxiliary function before this is defined. So this should break. And indeed, it tries to run it, and it says it's not defined. Now be careful, when I run IPython, now it has run here, and it ran there, and faux2 might be defined. It's not. It broke. Good. Okay, but sometimes if you try and run it multiple times, not for this code, but other things, once something gets defined, then it'll be okay, because you've run it and it holds it in memory. So be a little careful when you're running something. If you run it the first time and it breaks, and then it doesn't run, and then the next time it runs and it does weird things, try typing the %sign and reset. And what that'll do, it says here, is once deleted, variables cannot be recovered. It's going to delete all the variables. So I hit Y for yes, and now if I want to say something my driver 2, it doesn't know anything about those guys. Okay, so I have to go up here and load my modules again. But so that's kind of nice to just reset back to square one. All right, we just got a couple things left. The last thing to talk about is called scope. Okay, scope is where our variables and functions defined. So I can declare a variable here outside of a function, and this is called a global variable. Or I can define a variable inside a function, and this is called a local variable. So my analogy for this is, think about police. So the BYU police, they are local police. They only have jurisdiction at BYU. The FBI are police for the whole United States. They can have jurisdiction anywhere. Okay? Now sometimes the local police will take precedent, as we'll see in an example. All right? But you can see the FBI can kind of go anywhere and be anywhere. All right? So here I have a global variable. I call it a global, make 1.1. If I run this, what happens? I say print inside a. So I didn't pass a variable in. Normally if I want something to go in, I have to pass a variable in. I didn't do that here. I just defined a outside. So the function inside knows about the a outside. Okay, I didn't define it anywhere in here, So it says I'm going to go look, and I found the global variable out there. Okay, so it knows it inside and outside. But let's look at a local variable. Here I'm defining a local inside the function, okay, and I print it inside, and I try to print it outside. What happens here? Okay, it prints the inside version. A inside is 2.2, but A outside of the function, it doesn't know about it. So that's like a police officer trying to go, a BYU police officer trying to go to Arizona and arrest somebody. You know, the person in Arizona is like, you don't have any authority here. Okay, so A local isn't known outside of that function called print local. So what happens if they conflict? What happens if I name something globally and I also name it inside? What happens here? Notice that the inside one, the local variable, overwrites the global variable. So it overwrites it and says inside is 2.2, but outside is 1.1. But notice that it doesn't override it outside of the function. So it stayed as 1.1 even after I called print ABC. That means this one and this one are acting independently. And they will act independently just like this. Python has set this up on purpose so that you don't screw up your global variables unless you want to. So now you can change them if you want to, but you have to declare it with this global keyword. So if I say b global is 3, I can say, hey, I want to use the global variable b global and change it to 2 and now print it. And now look at what happens here. I call that function f, it prints it out, which is 2, and it prints it out here, which is 2, and that's it. Okay? To get it to be 3, I'd have to print it beforehand. Print b global. Before I call the function, I run that one. That gives me 3 first, then 2, then 2. Okay? So that's global and local variables. Ones that are defined inside functions, ones that are defined outside functions, and how they interact with each other. Finally, you can define global and local functions. So you can define a function inside of another function. And if that's the case, I can only use that function inside that function. I can't use it outside. So this is a local function, this inner function, and I'm defining it inside the outer function. And so when I call finner, it runs that piece. But once I'm now outside of that fouter function, that's the whole function there, I can't call finner anymore. It will break. Okay? It will run fouter, and fouter will print x in, x out as 1 and 2. Okay, finner, fouter, it's printing x in, x out, but it cannot print 3 and 2. It can only print 1 and 2. All right, so that's your quick introduction to Python functions. I hope this is useful, and I hope that you learn a lot and that your homework is easy for you. Have a great one.